In section 7.4, we're going to use the division properties of exponents. So what we have is in a quotient, the quotient property powers, the quotient of powers property says that what we're going to do is we're going to keep our base and we're going to subtract our exponents. Now, you can use that rule, but I'm going to show you the logic behind that, and you can also use the logic every time, and I'll tend to do that a lot because people understand it a lot better. This one's really kind of bad to start out with just because there's so many 10s. I have 12 of them, but I'll write them out. 4, 5, 6, 7, 8, 9, 10, 11, 12 10s. And on the bottom I have 4 10s. And what that means is that I could actually sit and cancel a 10 for a 10 on each one of these. What that does is it gives me 8 10s left on top. 1, 2, 3, 4, 5, 6, 7, 8 10s. That is the logic behind why we keep the base and subtract our exponents. So I'm going to go ahead and use that rule for the next part. If you want to write out 10 2s and 5 2s on the bottom, you will still see that you have 10 minus 5, which is a 5. You have 2 to the 5th left on top. Continuing on, we have more of these problems where we keep our base and we subtract 10 minus 7, which gives us 3. I almost hate to do this because when we start getting into the other problems and we have maybe a 3 to the 7th over 3 to the 10th, my 3 to the 3rd isn't on the top anymore, and I want to show you this. So there's 7 3s, and here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 3s. And when I start canceling these, the leftover 3s are on the bottom, so I would have to have the answer of 1 over 3 to the 3rd. So I caution using the rule of subtraction because we have to remember that we could end up with a negative exponent. And that's what happens. 7 minus 10 gives me 3 to the negative 3rd, and that's why they end up on the bottom. So on this next one, I keep the base r. 9 minus 7 is a positive number, so I do know it's r to the 2nd power. The next problem, I keep the n. This is n to the 1st. 6 minus 1 is 5, and it is positive 5, so I know I have it on the top of the fraction. The last one, I keep my h, subtract a minus b, and that's exactly how I have to write it, a minus b, because they're not like terms. Now we're going to look at some expressions, and so when we simplify these, we're going to use our numbers first. I find that a lot of students find it easier, especially at first, to write them out. So if there are no negative exponents throughout the problem, what is sometimes easier for them to do is to write down what this actually means. So it's 6a times b, and then I have negative 2a times b. So when I cancel, my b's cancel and my a's cancel, and I'm left with a b on top. And then you just treat your numbers as normal. 6 divided by negative 2 is negative 3. In the next problem, I have d on top and 7 d's on the bottom. When I cancel, I have nothing left on top, so that means I put a 1 there. And I have d to the 6th left on the bottom. Try to put a couple more problems on this video. So this first one says I have an a. I have 2 b's, b times b, and I have c times c times c. On the bottom I have a, and then c times c. The c's cancel, the a's cancel, and I'm left with b squared on the top and a c on the top. Alright, for our next problem, I have a times a, c times c times c over a, c times c times c times c times c. And I'll start canceling. And I notice I have a left on top and two c's left on the bottom. So I have a over c squared. The next problem, I'm going to use a calculator here at first. So I'm going to take 5, let me clear that, 5 times negative 81, or just 81, because I know that's a negative anyways. So I get 405. So I have 405 and negative 405. These two are just y squared t to the 4th over 45 t to the 3rd. So now I'll divide 405 divided by 45, which gives me 9. And I know it's a negative 9 because it's a negative divided by a positive. I have y squared left on the top because nothing's going to simplify with that. And then my t's, I'd be left with a t on top. Now, you really didn't need to use a calculator if you recognize that 9 goes into both 45 and 81. So you can make this 9 and make this a 5. And then what you could do is divide 5 divided by 5 is 1 and 5 divided by 5 is 1. So that's how you can end up with negative 9 without using a calculator at all. On this next problem, to start out with, I had two negatives. And I know a negative over a negative is actually a positive, so I'm going to change it to plus the opposite. So I really have 3 times x times x times x, y times y times y times y, over 2 x times x and y times y. So I end up getting my x's to cancel, my y's to cancel, and I have 3 over 2. I have an x on top and 2 y's on top, so I get my answer to be 3x y squared over 2. The next problem is a power of a fraction property, so I'm going to take each of the parts and raise it to the power. That's what the rule says. If it's divisible, we could go ahead and divide, but these are not divisible, so I'll just say this is 2 to the 4th and 3 to the 4th. Well, 2 times 2 times 2 times 2 is 16, and 3 times 3 times 3 times 3 is 81, so I get 16 over 81. On my next problem, I actually have something that's divisible, so I could just simply say this is 3 to the 3rd power. And then that would be 3 times 3 times 3, which is 27. On the next problem, we have some variables here, so we'll say that we have x to the 6th, 3 times 2, over 2 to the 2 times y, which would just be 2y. I cannot do anything else to those because they're not like bases. The next problem, I've got c to the 2 times 4, which is negative 8. And then I have d to the 12th power, 4 times 3. Again, they are not like bases, so I am finished with that problem. The last few we're supposed to leave our answer in scientific notation. Let's look at this a different way. This is 3 times 10 divided by 6 times 10 to the 6. Well, 3 divided by 6 is 0.5 times 10 to the, using the rule, 10 minus 6 is 4. This is not in scientific notation because this number is less than 1. So I'm going to change this into standard notation first, which would make this number be 5,000 because it's telling me that I'm multiplying by a large number of 10,000. I noticed that for me to put this into scientific notation, I need to place my decimal right here after the 5. So I'd have a number of 5, which is between 1 and 10, times 10 to some power. Well, it means I'd be moving it 3 places. And so I end up with 5 times 10 to the 3rd. On the next and last problem, I've got 2 times 10 to the 8th divided by 8 times 10 to the 3rd. 2 divided by 8 is 0.25 times 10 to the 8 minus 3, which is 5. I'm going to put this into standard notation first. So I'll be moving this decimal over 5 spots. Whoops, wrong way. This is a positive 5, so I'll be making this number bigger. So 5 spots this way. So I end up with 25,000. 1, 2, 3, 4, 5, 25,000. I need to place my decimal right here after the 2, so I have a number between 1 and 10. So I have 2.5 times 10 to the 1, 2, 3, 4th power is a positive number because I want my number to be just as large.